All right, thanks, Eldar. So I'm going to talk about some work with the RISE 2 survey team, and this is just a short list of the members that have contributed to this work, but we have a really broad team that we couldn't do all of this work without, so thank you to all of those people. So RISE has a really widespread goals in terms of trying to understand the surface of many different bodies and develop protocols to explore those surfaces and maximize the value of returned samples. And a subsection of RISE that we're focusing on here is...
I don't think your slides are advancing. Did you full screen them? They might be frozen. Okay, now the next one we see it. Okay.
Uh-oh. Okay. I'm just going to keep it in not the full screen mode. How about that? And we'll just wing it.
Whatever works. Thanks.
All right, great. Let's do this. Is that all right for everyone? Okay. Let me know if there's any other problems. All right, so the work that we're focusing on here is to develop scientific methods for human exploration using the Kilbourne Hole and Hunts Hole lunar volcanic analog site. And our specific talk here is really working to develop a concept of operations for different types of field portable instruments. All right, so we have had 2 field campaigns so far. The first was in November 2021, and then we just wrapped up a campaign in April. And so last fall when we were out in November, this was primarily to survey the different sites and to use our field portable instruments to collect in situ geochemical data. So we focus on 3 main handheld instruments. We have a VNIR spectrometer, LIBS, and an X-ray fluorescence bulk chemistry instrument. And then after that, we took that data and we tried to do some data processing for us to incorporate it into different types of EVA scenarios. So we can really explore how to integrate this data into different concepts of operations. So I'll go into a little bit in that in between November and April. Although we had 3 different handheld instruments out there, and this is in addition to aerial imagery from our UAV team, we have LiDAR reflectometry data, and we also have our hyperspectral data from our team at Stony Brook. We're focusing here on just our bulk chemistry. And so we used our XRF to analyze surge deposits and changes in terms of vertical exposure. But within this region, we have a variety of different rock types. And so we went on a search to collect all these different rocks and were able to put those into a rock library so that we could use a variety of different rocks in these different scenarios that we have. After we analyzed all of our data, we needed to process this. So what our handheld instrument displays after an analysis is mostly an element percent. So the percent aluminum, percent silica. You know, this is kind of hard. It's not the way that most of us geologists kind of learned to interpret geochemical data. And so one of the primary goals in taking the exported data off our instrument is to convert that into oxides so that we're able to visualize and interpret this more easily. Then we have to select some type of data product. So what are going to be the data products that are best for the different scenarios that we're in? And we'll talk a little bit more about those that we selected. But we also have to have a way to integrate and visualize these products when we're in the field. And the way that we chose was to go digital. We put together a Google Slides document that had all of our rock library and surge bed analyses. And so we could simply click on a rock that looked similar in the field, and we were able to see these different data products. So our EVA scenarios, we had 3 different scenarios. One was a geophysics scenario, which I won't touch on here. But the other 2 really required use of our geochemical data. And the first one had the science goals at Kilbourne here Kilbourne hole was to collect a diverse suite of samples in order to test a planetary differentiation hypothesis. A second kind of sub objective here was to collect samples with significant amounts of clinopyroxene, quartz, and olivine, so very specific objectives. In the Hunt's-Hell scenario, we had a different objective here, and it was to for our crew members to record observations, collect data, and if they decide, samples, in order to evaluate the eruptive history of those surge bed deposits. And that's not for the crew to evaluate, but to be able to paint a picture for those scientists back on Earth in this scenario. And so to kind of facilitate, in addition to our other data products that we have, we used our bulk geochemistry data and we came up with 3 different products. So the first was a compositional summary, and then we had 2 classification diagrams. So the compositional summary was a table of our oxides with some select trace elements, and then also a measurement quality in terms of, was that a good measurement or a poor measurement? And that was primarily assessed or based on the total that was measured. And then our classification diagrams, we had our classic task diagram for volcanic rocks, and then a sedimentary diagram, which shows, a ternary with silica with calcium plus magnesium and aluminum plus iron on the corners. So we learned a lot by integrating these data sets. Our test crew members were really phenomenal, and they consisted of both geologists and non-geologists. And so what we learned is really useful for feeding this forward into a 2023 test. So what we found with our compositional summary is that if you were a geologist and had a background in geochemistry, you might have used this table, but not necessarily everyone used it. And in terms of the measurement quality, people tended to, read out loud what the quality was, but it was really unclear how they were supposed to use that within the context of the scenario. And so going forward, we have some specific goals in maybe providing a more a target oxide percentage in order to make this table more useful in an EVA scenario. And then also to be more explicit about what factors contribute to a measurement quality so that the crew member is able to determine how to use that in further decision making. And so lastly, I'll touch on our 2 classification diagrams. So we had our task diagram and this sedimentary ternary diagram. What was really great about this is whether you were a geologist or not, it enabled a really quick classification. And so our crew members were able to immediately look at where that data point fell in the region, and were able to note what classification based on this method was depicted. And so this was really great because it was quick and easy and there was no interpretation required. One thing that was interesting is that because these data are based on geochemistry, it's possible to have points plot in both of the different types of diagrams. And so we really learned that going forward, whether it's for this scenario or others, things like flow charts and decision-making charts could be very useful when you're getting conflicting information in the field. And so we plan to look at how we can incorporate that. So lastly, I'll leave this up here, but we have a 2023 trip and we're really excited. These will be our high fidelity simulations. And so we've learned a lot from incorporating these data products, learned things that we need to change, and hopefully have really high goals for the future of how we want to implement not only our XRF data, but our other handheld data too. Thank you.